Hello everyone and welcome to this video. In this video, we will discuss another theorem which is what we call the rational root theorem. First, what is rational root? Or what are these rational roots? Suppose we have here the given polynomial p of x. Rational roots are the values of x that will make our p of x equals to 0. That is why rational roots are also called as the zeros of the given polynomial p of x. The rational root theorem provides us the list of all possible rational roots. And from this possible rational roots, we can determine which are the real rational roots of the given polynomial p of x. So, how are we going to use this rational root theorem to determine these rational roots? Okay, first, you will take your constant in your given polynomial. So, we will get the constant term in our given polynomial. And our constant term is negative 2. That is the constant term. And aside from the constant term, we will also take the leading coefficient. The leading coefficient is the numerical coefficient of the highest power in our given terms. In our example, x raised to 4 is the highest power. So the numerical coefficient of this is 1. And that is our leading coefficient, 1 or positive 1. So after identifying the constant term and the leading coefficient, we will list the factors of our constant term and the leading coefficient. So let us list the factors. So what do you think are the factors of our constant term, negative 2? So we can have positive 2 times negative 1. Why? Because positive 2 times negative 1 is negative 2. Another one, we can also have negative 2 times positive 1, because negative 2 times positive 1 is also negative 2. As you will observe from the listed factors here, we can summarize our factors of negative 2 as simply positive negative 1, because we have positive 1 and negative 1, and positive negative 2, because we have positive 2 and negative 2. So in other words, negative 2, our constant term, has 4 factors. Positive 1, negative 1, positive 2, negative 2. So after that, we will take the factors of the leading coefficient. And our leading coefficient is 1 or positive 1. So what are the factors of positive 1? We can have positive 1 times positive 1. Because positive 1 times positive 1 is 1 or positive 1. Another one, we can also have negative 1 times negative 1. Because negative 1 times negative 1 is also positive 1. As you will observe from our factors here, positive 1 is duplicated. And negative 1 is also duplicated. And we can summarize our factors of our leading coefficient 1 as simply positive negative 1. So we just write the duplicated as 1, right? So in other words, our leading coefficient, positive 1, has 2 factors, positive 1 and negative 1. Now, after determining these factors of our constant term and the leading coefficient, we will list now the possible rational roots. And how are we going to do that? So from the rational root theorem, the possible rational root is in the form of P over Q. Right? In other words, a quotient of P and Q. And what are these P and Q? P are the factors of your constant term, while Q are the factors of your leading coefficient. So we will list all these rational roots. Okay? So we will get the quotient of our factors of the constant term and the leading coefficient. So the factors of our constant term are positive, negative 1. So we will divide that by the factors of the leading coefficient. So we can have positive, negative 1 divided by positive, negative 1. Right? So one possible, or these are possible rational roots. Another one, we have positive, negative 2 divided by positive, negative 1. So we'll have positive, negative 2 divided by positive, negative 1. We can simplify this. So, what is 1 divided by 1? So, we'll have our possible rational roots are simply positive, negative 1 because 1 divided by 1 is 1. Another one, positive, negative 2 divided by 1 is 2. Therefore, we have 4 possible rational roots. Positive, negative 1, positive 2, negative 2. Now, these are just possible rational roots. Maybe one of them, two of them, or maybe all of them, or none of them are the rational roots. So, these are the possible rational roots. Now, how are we going to determine which of these rational roots, possible rational roots, are the real rational roots of our given? Now, from this listed possible rational roots, to determine which of these are the real rational root of our given polynomial p of x, we will have the test 0. What is this test 0? Just like what I have told you in my introduction, rational root is a value of x that will make our p of x equals to 0. In other words, we will evaluate our given polynomial p of x using these possible rational roots. So we will find p of positive 1, p of negative 1, p of positive 2, and p of negative 2, and see which of these will make our p of x equals to 0. So let's start with p of positive 1 or 1. So all you need to do is to replace our variable x here with 1. So we'll have 1 raised to 4 plus 2 times 1 cubed, right? Plus 1 square minus 2 times 1 minus 2. Okay, let's simplify that. 1 raised to 4, so 1 times 1 times 1 times 1, that is 1. Plus 1 cubed is 1. Times 2 is 2. Plus 1 square is 1. So minus 2 times 1 is 2. Minus 2. So what is now our p of 1? Okay, let's continue. 1 plus 2 is 3. Plus 1 is 4. Minus 2 is 2. Minus 2, the answer is 0. So in other words, p of 1 is 0. How about the next possible rational root? Let's compute our p of negative 1. Okay? So we'll replace x here with negative 1. So we have negative 1 raised to 4 plus 2 times negative 1 cubed plus negative 1 squared minus 2 times negative 1 minus 2. Okay, let's continue. So what is negative 1 raised to 4? So, since the exponent is even, negative 1 raised to 4 is still positive 1. Okay? Negative 1 cubed, the exponent is odd. Negative 1 raised to 3 is negative 1 times positive 2 is negative 2. Okay? And then negative 1 square, so even, so that is positive 1. Then negative 2 times negative 1 is positive 2. Then we have minus 2. Okay, let's compute this. So what is our P of negative 1? 1 minus 2 is negative 1. Plus 1, 0. Plus 2, 2. Minus 2, the answer is 0. So in other words, our P of negative 1 is also 0. How about positive 2 and negative 2? So let us erase first this. Let's compute P of positive 2 or 2. So we will replace x with 2. So we have 2 raised to 4. Okay, plus 2 times 2 cubed raised to 3 plus x is 2, so 2 raised to 2 minus 2 times 2 minus 2. Okay, let's compute. 2 raised to 4, that is 2 times 2 times 2 times 2, that is 16. Okay, plus 2 cubed, that is 8. 2 times 2 times 2 is 8 times 2 is also 16. Plus 2 square is 4. Then we have minus 2 times 2 is 4. Then we have minus 2. Okay, if you will compute this, so what is our P of 2? 16 plus 16, that is 32. Plus 4, that is 36. Minus 4, that is 32. Minus 2, that is 30. So it's meaning P of 2 is 30. How about P of negative 2? Okay, let's compute. P of negative 2. So our x here is now negative 2. So we have negative 2 raised to 4 plus 2 times negative 2 cubed, okay, plus negative 2 square minus 2 times negative 2, then we have minus 2. Okay, let's compute this. What is negative 2 raised to 4? So since the exponent is even, so negative 2 times negative 2 times negative 2 times negative 2 is positive 16. Okay? Then we have here plus, okay, negative 2 cubed. So since the exponent is odd, so negative 2 cubed is negative 8 times positive 2, that is negative 16. Then we have here negative 2 squared, so the exponent is even. So negative 2 times negative 2 is positive 4. Then we have here negative 2 times negative 2, so negative times negative is positive 4. Then we have minus 2. Okay, so let us compute this. What is our P of negative 2? So finally, 16 plus negative 16 is 0, plus 4, that is 4, plus 4, that is 8, then minus 2, the answer is 6. So meaning, our p of negative 2 is equal to 6. Now, from our computed values from the test 0, observe that p of 1 and p of negative 1 are both equal to 0. Meaning, positive 1 and negative 1, each of them makes our p of x equals to 0. So in other words, among the 4 possible rational roots, positive 1 and negative 1 are considered our rational roots. So, they are our rational roots of our given polynomial. So, we can write them as x is equal to positive 1 and x is equal to negative 1. So, they are the real rational roots of this given polynomial p of x.